So let's talk about the powers of 10 with the negative exponents. Like we did with the positive exponents, we need to write the expanded form. And one of the things that you need to realize about negative exponents is they are the inverse of a positive exponent. So we already know that 10 to the 0 power is 1. And again, we will talk about that in a little bit. The decimal form for 1 would be 1.0. So the inverse of 10 to the first power, well, we know 10 to the first power is equal to 10. And the inverse of that would be 1/10. So when we have 10 to the negative second power, it would be 1/10 times 1/10. So 1/10 is already written as a fraction. And as a decimal, 0.1 or 1/10. 1/10 times 1/10 would be, remember, you multiply the numerators and then you multiply the denominators. So we have 1/100th. As a decimal, 1.01. And we can follow the same pattern for the rest of them. And we get 1/1000th for 10 to the negative third power. And then for 10 to the negative fourth power, we have 1 to the 10,000th. And 10 to the fifth power, negative fifth power. One to the 100,000th. It's a lot of zeros. Okay? So again, like we did with the powers of 10 for the positive exponents, for the powers of 10 with the negative exponents, for class, I would like you to bring the answers to these questions. What patterns do you see? And there can be more than one pattern. And predict what you think 10 to the negative 9th power would look like. Then I want you to think about this question and bring your answer to class. In both tables, the ones with the positive exponent and the negative exponents, what connections can you make between the exponents and the decimal place? So I said we would talk about 10 to the 0 power. It's a common question. Why does it equal 1? Shouldn't it be 0? And how does it work? Those are common questions. So let's talk about it. I want you to look at the number pattern for these exponential forms. 2 to the third, 2 squared, 2 to the first power, 2 to the 0 power, 2 to the negative first, and 2 to the negative second power. And when you look at that pattern, you want to figure out what math operation is happening with each increase or decrease in the exponent. So let's talk about 2 to the 0 power. We know that's 1. Well, what math operation did I perform to get to 2 to the first power? 1 times 2 is going to give me 2. 2 times 2 will give me 4. 4 times 2 will give me the 8. 1/4 times 2 is 1/2. 1/2 times 2 is 1. So it's a number pattern that happens with exponents. And when you get to 2 to the 0 power, you will get 1. And the same works for the inverse. If we're multiplying as we increase, then we need to divide as we decrease. And I'm going to fix one little error here. This should be a 2. So we're at 8. What math operation did we do? We divided by 2. We divide by the base. Divide by the base of 2 to get the 2. 2 divided by 2 will give me 1. 1 divided by 2 is 1/2, and 1/2 divided by 1/4 is 2. So is 1/2 divided by 2 is 1/4. Sorry. So it's just a number pattern, and when you get to any number with a 0 power, it's always going to be 1. So for class, you should be able to figure this out now. 10 to the 0 power is equal to what? So that's all of the lesson for powers of 10. Make sure that you complete any notes that we didn't do together and bring them to class. And I will see you tomorrow.